I'm Kristen Finch, and I'm the Director of Research Computing Solutions with UW-IT Division of Research Computing. And one of our tenets in UW-IT is you get me relationships. And so that's what I want to tell you all the services that are available for your research through our team, and also to express that we want to be able to fit your needs. And so there are many ways that in the slide deck, you can get in touch with us, and the slide deck will be shared during this presentation over email. So research computing, we cover many services across UW campus for the UW community. One is our high performance computing cluster, HIAC. And this is a Slurm-based cluster. A lot of what Chris was talking about is compatible with HIAC, of course, and one of the main reasons that we're here today. HIAC, as I said, is a Slurm-based cluster. It is Rocky Linux. We use a lot of containers as well. It's a condo model, and the metaphor here, that's the business plan. The metaphor here is that if your research group contributes resources to HIAC, then you kind of own that condo. And then we're the building staff. We're making sure that all the maintenance is happening and that you have everything that you need to be able to use those resources with priority on HIAC. It also comes with storage, of course. You need storage for your research, but I wanted to talk about two of our other storage services that really complement well with HIAC for research computing. And it's not just for computing, these are really for everyone. And COPA, our new object storage service in particular, was in response to Google Drive limiting their quotas now for EDU participants. So you have a new storage option in town right here on campus. And also our low tape archive. This is a great service for your cold storage, and it has duplicate automatic geographic redundancy. So whenever you send your data to Lolo, it makes a copy in Spokane. So if nothing truly catastrophic happens, your data is safe. And I should say that all these services are actually just right below where we are sitting now. If you were downstairs one floor below, you'd just hear the GPUs just screaming on HIAC. It'd be deafening. Another thing is that UW-IT is actually a reseller of commercial cloud computing for research. So we have AWS, Google Cloud Platform, and Microsoft Azure options. You can get discounted rates by going through UW-IT as well as our fantastic support, which hopefully that's one thing that you'll leave this meeting knowing today. As data regulations come on board, we're also adapting to be able to serve your needs for secure computing as well. And if you just don't know where to start, we have a team, our research computing consulting, that you can email us and just let us know, hey, I need to expand my research computing platform, but I don't know which platform is right for me. And so we can help you with that and help you answer your questions about, well, you know, this works really well on my computer. I'm afraid it's not going to work so well somewhere else. Well, we have resources that you can try that out with us, looking over your shoulder. And all of this is to say is that we really want you to be able to stick to research, and we'll stick with the maintaining hardware and things like that. And one of the exciting announcements that we have this year that Mari was alluding to is that we have a new GPU cluster coming on board called Tillicum. Tillicum means the people in the Chinook jargon for trading in this region. Tillicum is going to be launched in fall 2025 and is 24 Dell servers. And these all have, across all of them, they have 8 GPU cards per server. So that's 192 H200 GPUs in total. These are high capacity GPUs for your big models because each of the cards has 141 gigabytes of RAM. The communication between these GPUs within the node is supported by NVLink, which has a theoretical bandwidth of 900 gigabytes per second. And then between the nodes, we have an InfiniBand network with achievable speeds of 400 gigabits per second. And of course, we have storage attached to this. There'll be storage supporting common computing data sets that hopefully we'll be able to outsource with the community to find out what you need, what data sets you would like us to be hosting for you, as well as scratch space. And I'm going to point out our event feedback link again. If you respond to the event feedback, there is a question about if you're interested in helping us assess Tillicum as an early access user. So you can let us know what you're willing to try out and we can help you with that. It's a way, kind of like a win-win, right? We get a little bit of assessment for our new cluster and you get some free computing, right? So, yep, check it out. All right, and so as I was saying, we have a user support team behind this, and that's really my role, is to be a leader for our user support in the UW IT research computing side. And our mainstay is our help desk. So if you email help@uw.edu with HIAC, COPA, Lolo, Cloud, Research Computing Consulting in the subject line, that ticket will get routed to us. Even if you can't remember that and you just describe what you're wanting, we have people that are triaging all the tickets that come into UW IT to get that to us. And then with our partners at the eScience Institute, we host across both teams, we host a number of office hours for drop-in each week. And so these are some of the domains that we offer, HPC and our AI, ML, all of these. If you haven't been to the eScience Institute, you should really go and check it out. They have an espresso machine in there and some other snacks. Sometimes if you're lucky, they'll have some other snacks to give away. That's on the 6th floor of the astronomy tower. Just pop up and say hi. Between our group and eScience, we offer many trainings per term, about three to four trainings at least per term. And from our team, you're getting HPC experience, and from eScience, software carpentry, pixel proficiency, which is deep learning, and then many different kinds of flavors of Python that you can learn there, as well as their weekly data science seminars are good to check out. If you want to know more about what's going on with research computing and eScience, you can check out the UW Seattle events calendar where we post our events. And also, if you go to the eScience website, which I'll link in this presentation, then you can find the link to sign up to their newsletter, which gives you access and updates about all of the opportunities there. One program that I really want to shout out, and this is perfect because Chris teed it up perfectly, that if you're not good at software, there's a program for you at eScience. So they actually have this data science and AI accelerated program where they're looking for proposals every quarter just to find people that need help. Maybe you're stuck on something. Maybe you want to push your research to the next level. You should apply for this program and you get matched with one of the eScience professionals to just learn your problem and provide you a new set of eyes on how you can meet that solution. All right, and all this is to say that users are a reason to come to work, right? We all love the hardware stuff. It's awesome. We got some new GPU servers that got unboxed recently, and we're going to be launching those. But there's no UW IT without UW in the research community. That's our main goal. And so I wanted to highlight some of our users. First is Patrick Boyle. He's an associate professor in bioengineering and adjunct in cardiology. His research has always had a big computing component because he does simulations on the heart muscle and simulating many different scales of that work, really focused on atrial fibrillation, which can cause complications like stroke and heart disease. And this type of work is just not feasible without high performance computing. And so when he became a faculty in 2018, that was one of the first things that he did was sign up for HIAC resources. And now he also uses our GPUs for a machine learning project to predict stroke and other cardiac arrest risk in pediatric cancer survivors, to see if they have a risk later on in life for additional hospitalization. Excuse me. Next is Hannah Hashi-Shirzi from the Allen School. She's an associate professor and also the senior director of National Language Processing Research at AI2. Hannah builds and releases the models open source. Some of the models you may have heard of are called Olmo and Tulu. Hannah uses HIAC and AI servers to train and evaluate these large-scale AI models. Really, the scaling needed for AI and the capacity is not possible without a ton of GPUs. So, and this tool here that I have the video of is called Show Olmo Trace. I think this is really awesome. It uses the Olmo model. You can ask it a question, but then you can say, how do you know that? And it'll show you even down to the sentence level of where it got this information. So you can trace back the AI training to the data point and figure out why is it saying that. Another one that I wanted to say would have been nice when I was in graduate school is called Open Scholar, which is a AI that feeds you scientific journal articles when you ask it a question. So that would have saved me some time for sure. Next is Tarang Kanaankar and his team at the Sahelish Sea Modeling Center. These folks Tarang developed the Sahelish Sea model, which accurately predicts the flow of sediments and nutrients in the Sahelish Sea. And the entire coastline is covered by measurement devices collecting variables all throughout time. And they provide these very fine scale models of ocean currents and sediments and everything else. And these water quality analyses are used to inform emergency preparedness for marine incidents. And this model is open source, and so it's publicly available. And so it's really fostered a lot of excellent projects in hydrodynamics, wildlife population connectivity, heat waves, and sea level rise, just to name a few. Next is Shane Steinart Thruckeld, and he's an associate professor in linguistics. His main question is to tackle our understanding, our ability to learn languages. Do we have this innate ability to understand languages, or how much of that is actually learned rather than innate? And he started using HIAC because his needs outgrew his departmental server capacity. And so he uses HIAC GPUs to run computational language models. He manipulates the data and tries to see what these language models are coming up with, if they're just regurgitating what they have learned or what we've given them, or if they're able to make their own rules and generalize. And he's found that there is some evidence that they're not just memorizing, they are able to generalize. And so he's connecting that back to how do we learn languages as well. Next is a postdoc, Matt Farr. He works with Sarah Converse in the School of Aquatic and Fisheries Sciences in Coend. He's using HIAC to get his life back. He's got a high volume of simulations, and without parallel computing through our job scheduler, it would take a lot longer for all of these jobs to run on his local computer. He can just send off one script and they all run magically. It's awesome. His work deals with testing models for monitoring species and conservation efforts having to do with marine birds like sea ducks and tufted puffins. Finally, I've got a graduate student to spotlight. John Yu Wang is from the Quantitative Ecology and Resource Management Department and working with Laura Prue. She's using HIAC free student resources for her degree program and doing simulations to better understand predator and prey interactions with different snow conditions. And it's mostly focused on the cougars, so our native big cat on the Olympic Peninsula. That's right, I said student-free resources. And so the Research Computing Club is an organization here at University of Washington, which has been successful in applying for student technology fee grants and accessing annual blocks to be able to make computing opportunities available to students. Every year, almost, they've added resources to HIAC. They're one of the biggest user groups. They've added 24 nodes to HIAC, and across those, we have 24 GPUs supporting students that can schedule priority jobs and also have computing storage. As well, they have a cloud credits program where they can apply for $500 of AWS credits. Plus, our team, again, for guidance and troubleshooting. They have an active Slack community where you can get help from your peers and also get notifications about events, as well as fellowships and jobs that are relevant for computing-focused folks, and an annual hackathon to check out. It already happened this year. You'll have to wait for next year. The student technology fee resources that are added to HIAC are not just for the Research Computing Club, but some instructors are also using these resources for their teaching. So Luna Wong from the Material Science Department teaches a course called Big Data for Material Science. And it's focused on engaging or building this workforce of folks that have data science experience for a manufacturing focus. And the aim with the HPC module that she teaches is to make HPC more accessible to students with no coding background. So try and lower those barriers to entry and demystify their environment setup. And this course uses HIAC as well as Google Colab and Azure, exposing students to multiple platforms that they might also interact with in their career. Next is Zach Sherman. He teaches Introduction to Molecular Simulation. Since becoming a faculty, he's been using HIAC right away. He does simulations that involve soft matter, so nanopolymers, colloidal suspensions. These are optimized for GPUs, so he needs HIAC GPUs. And his science has inspired his teaching, and so the students are running simulations and using HIAC for that, gaining exposure to high performance computing and coding along the way. And that's to say that one of our focus for this year coming up is really to engage with instructors and find out ways that we can help you with your teaching. And one of the things that we're doing, this will be on HIAC and on the future cluster Telecom, we've added an open on-demand platform, which I'm going to do a demonstration. This platform gives you a graphical user interface where you can engage with HIAC and not have to do any advanced SSH port forwarding. Trust me, there were many, many steps to set this up before, and now it is just open your browser and go. It's awesome. So if you want to follow along, you can, but we're almost to lunch, so I think I'm just going to show a few things, and then you'll be able to try this out on your own. Off campus, you do need to have the VPN to use this service. And everyone who has not used HIAC here today yet, I gave you a demonstration account, which is a limited account, but at least you can try things out. So Open On Demand looks like this when you get there. It's at ondemand.hiac.uw.edu, and it opens up with our blog. So if you want to hear about really more hardware things happening on HIAC as well as other events and things, that's another way that you can get a hold of that information. I think one of the best tools for teaching that we have here is our Files Explorer menu. So I can go to my home directory, which is your first directory that you're kind of spit into when you log on to HIAC Supercomputer. And I can actually interact with all of my files here as I would on my own computer with a file explorer. I can upload and download things. I can make new directories and move stuff around. It's also remembered that in my other storage spaces that I have access to, I've saved folders here as well and made them for myself. And these are automatically added as hot links over here. Next, I'll jump into our interactive apps. So to start up Jupyter Notebook now with running HIAC in the background, you have this formula submission. So this is my account, but if you have a demo account, it's going to look a little bit different. But I'll go ahead and show you that if you're a new user, you want to stick with these CKPT resources, these checkpoint resources. This is our community idle resources. These are things that just by being part of the HIAC ecosystem, you have access to. So even though you're not a Condo user, your group hasn't added resources, you're able to schedule jobs when the resources are not being used by other researchers. And that's from the checkpoint partition, abbreviated CKPT. And then you can choose your container. We have some added here for you. So the data science container has matplotlib and NumPy, things like that. And you can pick Jupyter Lab or Jupyter Notebook, the number of CPUs and mem that you need. If you select a GPU partition, you can choose a GPU here and run it for any number of hours that you want, at which time it will end if you don't stop it sooner. And you just launch that. It takes you into all of your jobs that are here. I have some jobs running. This is like a cooking show, right? It's like, okay, she showed me what to do and now here it's ready all of a sudden. So my Jupyter job is going to come up at some time, but I've already started up a job on our clone desktop app, our studio app, and our Jupyter app. And I've opened them in these tabs. So I'll go ahead and go into my Jupyter app. And just like what you're used to, if you use Jupyter Lab a lot, You have your notebooks here. You can run Jupyter Notebook just as you would, and you have your file explorer over here on the side connected to HiAC, so you can select your files this way. RStudio, easier than ever. You've got the same thing. You choose the RStudio container and you can run RStudio. You will, if you have a lot of packages, there is some container customization that our team can help walk you through. But look here, I made some plots about our registration by role. We have a lot of graduate students registered. Good job, graduate students. Yep. All right. And a lot of you heard about this event by word of mouth, which was really surprising for me. But thank whoever is talking about us. It's awesome. Finally, this is what our desktop app looks like. So this really opens the door to many things that you want to do. So of course, we have our supported apps, right? But any app that is running graphical user interface, which you need, you can launch it from this desktop. So this is running on HiAC. I opened up a command terminal. There are some things you kind of have to pick up that we can help you with. And I've launched from the ANSYS library, I've launched a Fluent launcher here, which may be something that you decide to use. I can also launch MATLAB this way. So MATLAB is a supported app, but you can also use the desktop to be able to launch that. So that's going to pop up. All right. Oh my gosh, 2 minutes to spare. Okay, let's go. Questions? Ashlar? Yeah, so the question was, is the remote desktop really a launched session, or is it what was it? Or an abstraction? And I don't want to be wrong, so people who are on my team, well, I'll just go ahead and say what I'm going to say. So when I open up a terminal here, it opens up and starts my command prompt on the node. So I'm not on the login node anymore. I'm on a node called N3379. So this truly is a node. I mean, it's running this application on top of it, but I can launch other jobs here if I want to. And that's how I launched this Fluent app from the Apptainer container for ANSYS. And then for MATLAB, I was actually loading it from a module with LMOD. I thought I saw another hand. Yep. Yeah, so the question is about the Data Science and AI Accelerator program from eScience. Rob, my eScience colleague, is here, so you just say no if I'm wrong. But the way that I understand it is that you get matched up with a professional to work on your project, and you have, an initial meeting to figure out. Of course, they when you apply, they learn about your project, so they match you up with someone that fits for you. And from friends that I have that were in this project, they're really after projects that are, short, could just be a week. You really just need someone to look at something and help you with it, or it could be a more long-term project. My previous lab that I worked with, they were trying to build a user interface to submit DNA sequences for elephants to be a public source for tracking elephant ancestry to combat illegal ivory trading. And so the data science professional was able to have multiple meetings with our lead coder on that project and be able to find this bug and kind of rework how that was happening. That was one thing. And then moving forward, I think they're still working together. So I think it can be a short relationship or a long-term relationship. Other questions? So the question was, do we have other applications for open on-demand service that we're hoping to add? And the answer is yes. And we've recently gotten additional staffer on who will be assessing those things and trying to find additional applications. This is also going to be available on Telecom, so we'll be assessing different ML frameworks and pipelines and things like that. The possibilities with open on demand are very impressive. This is a long-term project out of the Ohio State University, I think, Ohio Supercomputing. And there are some universities that have everything, even a certain bioinformatics pipeline that they turned into a formula submission. So I really think that this is my time to say, our queue, we don't have one on deck right now because we're focused on Telecom launch, but that we're taking suggestions, and we'd love to hear from you all on these common graphical interface type applications that are difficult to launch the old-fashioned way. Yes. Yep. the question is, does Hayek have modules like via LMOD to load certain softwares? And we do, but you have to be on a compute node. So for example, I am on a compute node right now that I've got. So when I showed the interactive sessions, these are all actually opened up, some of them on different compute nodes. So it's showing my host here. So some of them are running on the same actual physical server, and some of them are distributed around. This one I can, so it loads a little slow because the list of, oh no, it didn't. Oh, sorry. I have to do module avail. So once you're on a compute node, you can actually load the list of modules. The ones here at the top are the modules that we support. So these are like the most difficult ones to install, I would say. And we also take suggestions on which things to add in this way as well. And then you can also have your own group modules added. So you have a specific storage space for your group. And then depending on how loose you are with the permissions, those modules can also be used by other users. So yes, we do have modules. You just have to start a compute node job with SLOC and Slurm first to be able to see them.